Good afternoon, everyone, and welcome to today's webinar, the 5 best use cases for container technology. My name is Kevin Vogel. I'm the Vice President of Virtualization and Cloud here at Champion Solutions Group. I'll be your host today. We have on the line with us Tom Gummel, who is part of Champion Solutions Group. He's our lead technical Red Hat person at Champion, so he's going to be able to probably answer any questions you might have. We also have Matthew Ward from Red Hat, who's a real specialist around containers, around OpenStack, and I think you'll see that Matt's going to add a lot of value to the webinar today. He's going to be our main presenter. There are going to be 3 poll questions that we're going to be asking you as part of this webinar today, just so we make sure that our content is right on point and that we covered the topics that you want us covering. There's also in your Go to My Webinar application a questions box that I'm going to be monitoring as Matt and Tom go through all the information. And please ask questions during the webinar. If we can, we'll try to stop the webinar, answer the questions as we go. If we don't, we'll answer them all at the end and make sure that you guys have the information that you need. With that, I'm gonna start off here and just give you the agenda that we're going to be covering. As you could see, we're doing the introduction. Matt and Tom are going to be doing an overview of container technology, what it is, how it affects you. Containers don't equal virtualization. You'll see why that's so important. The 6 facts about containers. And then, of course, the 5 best use cases for containers, and then we'll talk about the next steps, the things that you can do to get more information or start thinking about containers for your environment. For those of you that don't know Champion Solutions Group, we really concentrate in these 5 areas, and I think that containers and OpenStack, fit into almost all of these, especially if you're doing anything with mobility, whether it's application or application development or deployment. You'll find out that containers is a great way to start looking at that. Cloud, obviously, this is a big part of everything going forward. Security, and you'll see from Matt and from Tom how security fits into the big picture here with containers. Data management and analytics. One of the things about containers is you still need to access data. You still need to be able to get to the information that you need. And then, of course, professional services that Champion does along with consulting is a big part of what we do going forward. With that, I'm going to hand it off to Matthew Ward, who's the Red Hat specialist that's hosting the call today. Matthew?
Hi, my name is Matthew Ward. I'm a solutions architect with Red Hat. So I wanted to take a few minutes before we dive into the container discussions and just kind of discuss Red Hat in general. Sort of establish some of our street credibility. We're the #1 open source company in the world. We were the first billion-dollar, with a B, open source company. And we just announced last week that we were, for the first time, the very first $2 billion open source company. So we're in approximately 90% of all Fortune 500 companies. This is from a 2014 poll, so the numbers are actually probably a little bit higher. We cover everything from healthcare to airlines to federal government space. We're in pretty much every market that any type of operating system or IT is in. We also have about 8,000-ish employees. I think we're growing to maybe around 9,000 now. And we're a publicly traded company. 85 worldwide offices. And this is just sort of Red Hat in general. We have, across the board, won many awards with the solutions that we have to offer. Today, we're only going to be touching on just one piece of one solution, and that is a much broader picture and of our whole content portfolio. Okay, so the reason why we were talking about Red Hat Enterprise Linux, and we asked that question, is that the container story is really a piece of the Red Hat Enterprise Linux story. So let me lay this out for you. Before I worked for Red Hat, I was working as a production engineer with the public sector and a lot of different government agencies. I've been doing this for approximately 12 years. And in the environments that I worked in, I can tell you there was two major IT houses, we'll say, or domains. And those domains were the development group and the operations group. And if you've ever worked in operations, you know those crazy developers are always asking, always demanding, and always trying to get more out of what they're trying to do. Almost in a Game of Thrones-esque type fashion and machinations, the operations department is always working to try and maintain their domain and hold on to their domain and keep all of that. And the reason why the development and operations have two fundamentally different goals. Outlined here, as a developer, the main goal is to get their products to market. So they're probably developing applications that either directly impact customers or help the back end influence customers. So they care about time to market. That's usually where the business is coming down, and the line of business people are pushing them to say, hey, we need to move faster. We need to get there faster because we need to beat our competitors. They also care a lot about scalability. They want to be able to take their application and they want to be able to run it anywhere. They want to be able to run as many instances as they want, and they want to be able to maintain the control of the resources that they want. How often does a developer look at the minimum specifications and then come to the ops team and request only the minimal specifications? It's almost never, I can tell you that. And the operations team, they're in charge of maintaining everything and keeping it all up and running. They're the guys who live and die by the 5 nines, 6 nines, 7 nines, depending on their environments. If you're working in regulated environments and say financial or in public websites that are being used by millions of people, you need to be able to guarantee those levels, service level agreements, and you need to be able to maintain all of this while trying to give in to some of the demands and the desires of the development team. So there is a tool to kind of help with this, and it takes more than just a tool. It takes a full cultural shift. But if you can go to the next slide, please. Containers can help bridge that gap and act as a tool because both from the developer side and the IT operations side, it can add a lot of benefit and it can get them communicating where it wasn't before. So again, in the same Game of Thrones reference, we can kind of tackle the same enemy and join an alliance so we can do that. Next slide. So what are Linux containers? In short, and we're going to go into a lot more detail in this, but a Linux container is a packaged application that runs on top of the operating system. So if we see on the left, we have our developer here. The main concerns about the developer, the developer concerns are the runtime or the framework application, and finally the application. But from an ops perspective, they care about the host operating system and they care about the physical servers themselves. So the responsibilities are by design almost separated unless you're working in a cohesive DevOps environment, which again requires a huge cultural shift, but also requires a lot of a technology shift. So next slide, please. I'm going to walk through the example of a container lifecycle. So this kind of gives you a little bit of an overview of what the containers are and how the lifecycle of a container exists. With that, I want to point out that starting from the left, at the very bottom, we have a base image. So we throw around the word container a lot, referring to Docker, or in this case, we do use Docker, but we just kind of use the generic term of container. Now, there's also another piece of the nomenclature which we don't bring up much, but that is what's considered to be an image. So on the bottom, the image is a read-only piece of the pie. So the container is actually the read-write capabilities on top of that. So starting from the left, the read-only is the base operating system. So we build from a base. That is your core operating system, whether it's CentOS, Fedora, or Red Hat. You need to have that base operating system to start with. Then you would install your framework on top of that using the read-write. At this point, you commit your container image, and then that turns that image and all of the packages that we just installed with Python into a read-only version of it. On the next level, we install our framework. In this case, it's a web framework called Django. And Django is a flexible web framework, and after we have that installed the way we want it, what we would do is we would commit that container to a read-only image, and then we get another container on top of that. And that's when we would install our web application on top of it. In this example, I'm using Rivet, which is a Twitter clone. It's an open source. It's not really meant to be used in any type of production, but it just shows the general workflow. And we can continue to stack these images on top of each other, and then we use the read-write layer to inject the new information into it. So with this being said, managing the lifecycle of the containers from an administrator, an IT ops point of view, it gives us that capability of really controlling it, and we know the image that we create will be the image isn't going to change at all. So it gives us some kind of assurance. I wouldn't call it a security, but it gives us almost a security blanket to hold on to. I know this is my core image. It's built the way that we built it, and nothing can change those layers. So next slide, please. So what are the top 3 benefits based upon the role? So in IT, we have our 3 primary roles. We have app developers, IT architects, or in a lot of cases, this kind of, your CTO falls into this line, and your operations people. So on the app dev and the IT operations side, it gives them a higher quality of release for their application. By knowing that you can save these images off and they're read-only, you only need to add the new data to it, it makes sure that the release that you put into development, you move into the testing QA phase, and that you move into production, bits aren't changing along the way. We know those bits are solid, which allows us to put some assurances around that. It gives us better application scalability. So if we have interconnected capabilities in there, we know that we can scale out much, much larger. And we'll talk about scalability a little bit later. And then the greater application isolation. So as we have different libraries and as we have different applications installed, a container is really virtualization of a process. So we'll talk a little bit more about that in a little bit too. So from the operations point of view, we have higher quality of release. We have an efficient replacement for full virtual machines. And we'll talk more about that, but a container has a base operating system that connects to the host. So we're not replicating the operating system over and over and over again. And finally, it's easier for application management. Because all of these applications are isolated in different containers and different processes, it allows us to quickly run concurrent applications on the same host without worrying about them tripping over each other or overlapping. And finally, from the architect's point of view, it gives us faster scale out. So we can move these workloads around and into different types of environments, which we'll discuss later. It also gives us a shorter test cycle. Since we know that we have this read-write layer, we know that those bits aren't changing. So we can rely on certain assurances that are provided there. And finally, we have fewer development errors. Next slide, please. So what we're going to do is we're going to discuss the 6 misconceptions about containers. So true or false? Please read through this list and just take a moment to read through and try and figure out whether you think these are true statements or false statements. If you would like to do another poll, now might be a good time too. All right, next slide, please. So containers are not a new technology. Next slide. In this, we can see the life cycle of we can see the history of a container. And this is actually kind of a late start. We actually have, back in 1998 and a little bit earlier, we have Chroot and other pieces. But this all originally started with BSD jails. So the idea that these administrators wanted to be able to put isolation around processes and manage that isolation, almost as if they were virtual machines. What eventually led to this is looking over in the 2008 section, the kernel and user namespace. This is a piece that allowed Linux to carve up its existing file system and its existing operating system into different user namespaces. And then LXC containers, which is what Docker uses as its underpinning technology, was developed shortly after that, in also 2008. So Docker is the giant whale in the room, so to speak. They were founded back in 2013. In 2013, they were working at .cloud, and what they were trying to do is they were trying to solve infrastructure problems. They actually weren't in the infrastructure business, but they were trying to find a way to scale their application rapidly and to do it using containers in a reliable way. And that eventually led to a spin-off of and open sourcing of the Docker product and the founding of the Docker community. In 2013, Red Hat released Red Hat Enterprise Linux version 7, which was built for cloud technologies and included some of the technology required to maintain applications that are running in containers. Kubernetes is another big piece sponsored by Google, and we are going to be releasing a RHEL Atomic, which is a atomic version of this environment. It's an ultra slimmed down version of the kernel running Red Hat, and it is designed for running and production level containers. Well, perfect. I'm going to touch a little bit on that for just a moment and discuss what our Azure relationship is. So if you were looking to try our Docker containers today, or the Red Hat containers, and you would like to do it in a safe, hourly, provisionable way, Azure is a perfect way of doing that. So we have a unique relationship with Azure that allows customers who are purchasing Red Hat Azure instances to actually get support from Red Hat themselves, and they don't need to go through Microsoft for that support. They're perfectly capable of doing that, and we actually have engineers sitting at Microsoft that are dedicated to helping Azure cloud customers with Red Hat transitions and handling a lot of those Red Hat questions. So that is actually a unique agreement between Microsoft Azure and Red Hat Linux. We do not have that same agreement with some of the other cloud providers that are out there.
So that seems to me to be a pretty good place for app dev if you're using containers.
Absolutely.
Okay, great.
So the next is containers are enterprise ready. And next slide, please. The reason why we can say that firmly without any question is that Google themselves are running everything that they have from search to Gmail inside of Linux containers. And they're utilizing containers, Docker, and they're also using another tool called Kubernetes, which we won't really cover in this, but it's a technology that helps manage containers, couple containers together, and deploy them into production environments. And Red Hat actually offers a service for app development if you're looking at simply doing platform as a service using open source software. Red Hat has hundreds of deployable frameworks and database applications that you can deploy on the fly. So that's Red Hat OpenShift. Again, we're not going to talk too much about this today. If you're interested, contact Champion and we can get more in depth into OpenShift with you. But OpenShift currently is running over 2 million production applications for our Red Hat customers managed by Red Hat. If you're interested, go to OpenShift.com and look at the OpenShift online offering. We have free gears that we call them, which are containers that you can spin up for free and test inside of Red Hat, managed by Red Hat, completely for free forever. We charge simply if you want to use more than the 4 containers that you are allowed. So, next slide, please. Why the OS matters to container-based applications. Next slide. The difference between traditional operating systems and containers is we're moving the libraries and the application into the isolation layer. So we have a slide later on that's going to discuss the differences between virtualization and containers. But if you just look here, we have one host operating system. We have one kernel that is communicating, separating all the isolation, and then managing all of those containers. So they're all communicating with the host operating system's kernel, which, as we'll discuss later, can really increase the speed and the performance of container technology versus virtualization. So the other thing that's very nice is if you've ever been in an IT production environment or even in a development environment, we have customers or development groups that may want to have different versions of a similar library, but there may be direct contrast or direct problems with having these libraries exist on the same server. So let's take different versions of Java. How many versions of a Java do they release a week? 4 or 5? Who knows? The thing is that we want to be able to run all of these individual versions of Java, and that's what we put as these libraries. And then that application doesn't need to worry about being rewritten whenever Oracle or Java decides that they want to change the way the method calls are being done inside of the whole Java runtime module. So with that way, you could run a version of Java and you could run your application and you'll know that that version will run forever. Because remember, if it's saved as a layer, it's read-only, never changes. So with that being said, we can also have different disparate versions. You can have the same application running in isolation from each other. So I could have 3 of the same application that each get their own namespace. They don't have to worry about stepping on top of each other. We don't have to do some fancy things with the file system hierarchy. We don't need to do all of those weird kind of parlor tricks that a lot of those IT ops guys had learned to do over the years. Next slide, please. So containers are not universally portable. But wait a minute, if you've ever read anything about Docker, that's what they say. They say that everything is universally portable. Next slide, please. If you take a look, an application that is running, or a container that is running on Ubuntu does not guarantee that it will run on a CentOS box or even a Debian box. The reason being is that it's so tied to the kernel. A lot of these applications, we call them userland tools, are so tied to kernel features. If they do not include all of those features in all of the kernel versions, you will start running into problems. And those problems can add up fast and they could be very difficult to debug. So you want to make sure, for example, Ubuntu tends to use some of the bleeding edge kernel versions. We have a kernel version that we maintain that is a stabilized version of it, and then we backport patches into it. So if you're running an Ubuntu kernel, they may have features that aren't in RHEL, or we may have features in RHEL that aren't necessarily been compiled and used for Ubuntu. Next slide, please. But the one guarantee that we can give you is that if you run your containers on either RHEL 6, Red Hat Enterprise Linux, or RHEL 7, that we can run any container running a Red Hat container on a Red Hat host across any piece of infrastructure. So what does that mean? You can run bare metal. You can run your containers if you have your operating system on bare metal. You run a virtual environment running Red Hat. You can run your Red Hat containers on that virtual environment. And you can move in any direction just by moving those containers around. There's no rebuilding, there's no recompiling. You just simply move it to that location, onto that server, and it runs. This little dark storm cloud we have, that's what we consider to be our picture for the private cloud. So if you're running Red Hat OpenStack, or a different distribution of OpenStack, some type of private cloud, or if you're running something like VMware vCloud, it allows you to, if you're running Red Hat, again, run these Red Hat containers. And finally, Azure is our first-class citizen, but we also support Google Compute Engine, GCE, and we also support Amazon Web Services. If you're running Red Hat on those services, you can also run your Red Hat Docker containers on there as well. Next slide, please. So what does Red Hat contribute to this other than different than the open source community? So at Red Hat, we are very firmly and very strongly a community member. We believe in open source. It's at the core of our being. What we do is we tend to come into these and we try to be a voice for the enterprise. We try to be a voice for our customers into these communities. So how we do that is we try and drive standards and we try and drive containerization to where it needs to be. So a few years ago, this was a very immature technology. And there weren't things like process isolation. That was something that Red Hat put in there very strongly, utilizing our SE Linux kernel module inside of our operating system to do that. We also work with the Open Container Institute to formally work on the different versions. So there's currently 2 different competing technologies out there for scheduling or working with different container technologies. There's 2 different formats. There's the open format and then there's the Docker format. Red Hat is a member of both, and we're trying to help bring some sanity and standards around both of them so that as our customers and champions customers, you guys can utilize and get the benefits of that from the get-go. We also work with the Cloud Native Computing Foundation on Kubernetes. And again, as I mentioned earlier, Kubernetes is a way of taking your application, breaking them down into microservices using Docker containers, and then putting a logical wrapper around those and forming a pod. And what that means is basically if you have a web application, you need a way of persistently storing your data into some type of database. So you want to have those 2 applications or containers separated for scalability, but you want them to be able to be kind of deployed together on maybe the same server, or maybe you want them deployed highly available across different servers. And then with Kubernetes, we can certainly set a replication factor, and it will take our application and our pods, so our database and our web application, and maybe you'll have a load balancer in there, and we can say, hey, we want to replicate this 3 times. And this is what Google does, and this is how they get their availability, where you never hit Gmail and it fails. You never hit Google search and it just fails. And finally, we have our own Docker container registry. So we worked on and we pushed the standards to help get a installable local registry. Before last year, the Docker registry, the only one that Docker knew how to speak to was the one that was created and ran by docker.io. So now we worked with the community and we worked to help get those standardized so that now you can install a local registry on your own network and you can manage your containers that way and you don't have to rely on the community. Next slide, please. So containers are not secure by default. As my slide shows, it's a slippery slope. Next slide, please. In here, when you're deploying a container environment, it's a lot like a shoji environment, if you go back one. Those Japanese houses. So you have one house, but you have many paper walls dividing these up. And this is what containers shows. This is what containers are to begin with without any type of security implementations. Next slide, please. We want to be able to show that we are more like a bank where you can have a vault in between each room. There's no way for you to quickly punch a hole from one wall to the other. Next. So how does Red Hat accomplish this with our container security? So what we do is we separate the host operating system. So this is the operating system that's installed on your bare metal. And we use a kernel module called SE-Linux to tag all of the processes and all of the files on the operating system. So what SE-Linux allows us to do is it allows isolation between containers, but also between processes. So for example, our IT ops guys, they're worried about this Java implementation, or they're worried about this HTTP Apache web server. There's a vulnerability that came out last week, and they haven't had an opportunity yet to install the updates. They come in on Monday morning, and they find out that that process has been exploited, and they've been able to compromise that Apache HTTPD server. What that means is, without SE-Linux, they would have access to that process and everything that process owns. So they would be able to manipulate things like home directories. They'd be able to install software. They would be able to gain any type of root level access that that system had. But the way SE-Linux works, and since it tags everything and the kernel manages those tags, it's able to take that process, tag it, and without those tags, it's not able to break the isolation of that container. So for example, in the first example, if you had a web server that was compromised and you were running a database on that same server, well, guess what? They may have the credentials to install and get into or modify, log into your database. With that being said, with SE-Linux, it allows them to carve up, and because those tags aren't there, they're not able to do anything outside of the HTTPD process. So they will still have ownership of that process, but they won't be able to break that barrier and get to the other processes on the system. So they won't be able to read things like home directories. They won't be able to create files. They won't be able to do things like that. They'll only be able to do what the web server is able to do. Finally, secondarily, all sources are trusted. So out on Docker.io, they have what's called the Docker Hub. And a study from 2015 shows that 36% of the Docker containers that were out there were vulnerable to a known vulnerability. So what does that mean? That means they took a scan, probably some type of Nessus scan or something, right now, one of those tools, and they scanned all the Docker containers that were out on the Docker registry, and more than a third of them were vulnerable to some type of vulnerability. Meaning, if you just pulled from their registry and ran that application, someone would be able to compromise that machine. So, Red Hat saw this study and said, whoa, 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 we need to step back for a minute. We need to think about this for a minute. We need to work with a company so that we can inspect the containers as they're there. So we can see what applications are installed on those containers and then determine if those containers have any vulnerabilities in them already. It's like, okay, that makes sense. So we started working with a company called Black Duck to be able to get that functionality. And after we've done that, we started creating our own registry, a registry that we trust and that we can say with some level of certainty that the core base operating system has been updated. So you could take our core Docker image, install your application on it, and you know at the time of you installing that application, the time you pulled that we had all the patches and security releases in that system. But that only works for a certain amount of time. This stuff's temporal. Every day there's new vulnerabilities that come out. So we need to have a way of being able to keep up with that system. And so Red Hat has introduced the Red Hat repository. Next slide, please. So the Red Hat container certification process. What this does is allows you to get from a trusted source, which is Red Hat, to host your containers. Trusted content from the containers, which will include security fixes and handle the enterprise lifecycle, and it's also portable across different hosts. Next slide, please. So containers do not equal virtualization. Yikes. We've been comparing them a lot to virtualization here. So when we say it's not equal to virtualization, what do we mean? What we mean here is that if you look at the diagram, you are running on the left to run a virtual machine on a virtual host. You have the bare metal server at the bottom. You have your operating system layer, which depending on who your provider is, if you're using Red Hat Enterprise Virtualization, then you may be running the Red Hat Hypervisor or Red Hat Enterprise Linux. Or if you're running, say, ESXi, you're going to be running a BusyBox operating system, and then the hypervisor layer is the VMware tools that are on there to do the virtualization piece. But either way, you have to have a core operating system speaking to that hardware. You know, I heard something at a talk not too long ago that said, no matter where you are in the development cycle, eventually you do have to talk to the hardware. So from that, with the virtual machine model, we install another guest operating system. Then we install our libraries and our application. So what that means is that in this model, we currently have 4 operating systems that we need to maintain the security of, and that we need to maintain all of the lifecycle and patch management of. The core underlying operating system that's attached to the host, and each guest operating system that is currently running our framework and our applications on top of that. With the container model, we remove the guest operating system model, and we remove the hypervisor, and you're directly speaking to the Docker engine, which sort of takes a similar role to the hypervisor, but it's a little bit different of an approach. So one of the big benefits to this is that we're now maintaining a smaller number of operating systems, but we're also maintaining a better performance stack. If we were to take a look at the virtualization on the left, if my application needs to call it needs to process. It needs to be able to process something. It needs to be able to move something from CPU, calculate, and then move that into RAM. So what has to happen is your application has to make the call to the operating system, or the framework. The framework speaks to the guest operating system. The guest operating system speaks to the hypervisor and says, translate this to the underlying operating system, which then it does translate to the underlying operating system, then reaches to the hardware, then carves out the CPU and carves out the memory, passes all that back up the stack. Then the application has to use it. It has to go back down the stack again, do the calculations, store it all, and get it all back again. So you have a much longer pipeline, and you're also building a ton of overhead. With the container model, it allows you to speak to the Docker engine, and then from that Docker engine, it speaks to the host operating system through the kernel, and then it actually communicates to the hardware that way. So you're not speaking to 2 operating systems and 2 translation layers. Instead, you're speaking to a translation layer, then to the main operating system that's talking to the hardware. Next slide, please. So, 6 facts about containers. Containers are not a new technology, as we discussed. Containers are enterprise ready. The OS matters in the context of containers. Containers are not universally portable. They are not secure by default. And containers and virtualization have different use cases. And I don't want to make it seem like we're saying containers are the best thing since sliced bread. And I don't want to make everyone here think that we're saying that you should move off of virtualization. Virtualization definitely has a place, especially when it comes to whole application isolation. It's a little bit deeper, and it's a little bit more, having those extra operating system layers really does give you some flexibility. But this is a new way that we're trying to consider when you're moving into new workloads. So next slide, please. So containers on RHEL, or Red Hat Enterprise Linux, is they're trusted, they're portable, and they're integrated into the operating system. Next slide, please. So finally, just to kind of reiterate a lot of what we've talked about so far, I'm going to go over the 5 use cases. Use case number 1, continuous integration and continuous delivery. So if we have a pipeline with our containers that allows us to inject code into them and build them on the fly, we haven't talked much about this. This is more of an advanced technical topic. but we have the capability of building a Docker file, which is a way of layering all those layers and getting the container to run, all in a easily readable scripted format that's using a type of markup language. So we can kind of describe what we want. We can inject actions. We can inject things like commands into it, installation options, and those type, and we can deploy it. So if we're working with new code and we're looking at being able to modify our code rapidly, and we want to be able to make rapid successive changes to it and deploy a lightweight container, so maybe we can just do it for testing. It allows us to continuously integrate and continuously deploy our system. It's really the development use case there. Number 2, infrastructure commoditization. So what does that mean? That means that if you have the hardware today, you can use the hardware, or you could use a virtual machine, or you could use a cloud instance. We give you that capability of being able to decide what works best for your budget, what works best for your company, and what works best for your customers when you're doing those decisions. You're no longer saying, well, we're tied to hardware, or we're tied to this public cloud. How do we bring that cloud in-house? How do we bring our workloads from that cloud in-house? If you have containers, it allows you to easily port those applications all around, anything that's running on top of Red Hat. So those are the different environments we talked about earlier. Application isolation. So this is super big. We talked about this a little bit earlier about how we can run different unique versions of a library and the application on different levels. So it allows us to not mess up what we're doing by running updates or patches, and allows us to get in front of all these changes by having a fallback read-only layer that we know we can kick back to at any point in time. Server consolidation. So we didn't talk much about this during the virtualization piece, but I have a rule of thumb when I'm talking about physical to virt to containers. And that's a 110-100 rule. So if you have one piece of hardware, the rule of thumb is you should be able to run about 10 virtual machines on that one server. For every 10 virtual machines that you can run approximately 100 containers. Because we're not redundantly and continuously reinstalling the guest operating system underneath, we're saving space. But since we're also talking to the kernel that's communicating with the hardware, it also shortens that pipeline of communication and makes performance significantly better. So we can get a significantly deeper density on our existing infrastructure. And finally, multi-tenancy. So if I have two developers that are co-working on an application, they can either choose to work together, or they could deploy the same container multiple ways and use their Linux namespaces to separate the differences and to keep those from overwriting each other or talking to each other or overlapping, and being able to communicate the ways that they want to be able to do that.
Thank you very much for answering our polls today. And our last slide, that this is just a nice place for you to take a next step. You can contact your Champion Solutions group for details about running containers. We have our own website, www.championsg.com. You can learn more about Container Development Kit, which I know Matthew was talking about, and that's on Red Hat's site. Learn more about that Atomic Enterprise platform that Matt mentioned earlier. Matt, I believe that's like a optimized kernel to run containers. Is that the best way to explain it?
Yes. It cuts out all of the extra pieces of the Red Hat Enterprise Linux operating system and only leaves in the pieces that are required to run container applications. So it doesn't include things like the KVM, the kernel virtualization module. It doesn't include tools like ping and traceroute. You need to actually install those inside of a container in order to get that functionality. So it is an extremely lightweight. It's around 300-ish megabytes, I think, at this point, to install the full operating system for Atomic.
Okay, great. And then, of course, OpenStack website on Champion's website. We'll be sending this presentation out to everyone that attended today, so you'll have all these hot links ready to go. What I'm going to do is open up the floor two questions. Like I said, we have Matthew on who's done, I think, a fantastic job today explaining containers and how they fit. We also have Tom on the phone that has actually worked with these hands-on, just like Matthew, that might be able to answer some questions you might have going forward. We'll open up the lines here. And Tom, I don't know if you've unmuted yourself. I don't know if you want to add any comments to what Matthew has talked about here.
I'm unmuted. No, I thought he did a great job there. So I'm kind of eager to hear from the audience out there any questions you have, and you know, yeah, happy to answer anything I can. So.
All right, in your little question box on your Go to My Webinar app, you should be able to ask a question either there or in the chat box is fine. We're monitoring both of them. This is just to let you know, this is one of Champion's webinar series that is going forward. We'll also be sending you out our calendar so that you'll get to see all the other webinars we have coming out around OpenStack, around obviously any of the other things that we're covering here. So we got a couple questions here. And the first question from Mike says, will there be a Windows version? So I'm going to ask both you, Tom, and Matthew, do you know if there's a Windows version coming out?
This is Tom. So in terms of Windows version, I'm assuming the question revolves around containers. And I have to preface this by saying I don't work for Microsoft, obviously, and I can't promise anything on behalf of them. But the indication is that they will be using some form of containers as part of their server operating system after 2016. And that's at least the general information I've heard. And I'm looking forward to some actual, things we can work with and play with. But I don't know if anyone else here has a different answer than that.
This is Matthew. I can't speak for Microsoft either. I know that some of the functionality that they were looking into was being able to run containers on top of the Microsoft operating system. So how they were going to do that was they were actually going to be running a virtual instance and then kind of connecting their PowerShell to that virtual instance, sort of as a streamlined pipeline. So it won't look to you like you're running a virtual machine in the background, but containers are so tightly coupled to the Linux kernel that to disassemble that and to rewrite that, it seems like it would be a monumental task. So I know that there were some talks that I've been in with the Microsoft people, how they're sort of running a virtual machine in the background with a Linux kernel that's kind of exposing it to PowerShell. So hopefully that answers your question. I don't know what their future plans are, if they plan on, with this like new Bash announcement that they released, if they're going to be able to maybe tightly couple the containers or be able to do anything with that container story, but I can't speak to that.
Yeah, I was going to mention that.
I guess the shorter response to that is we don't know, but we're optimistic, and probably, as Matt was saying, going to be more of that virtualized instance.
All right. Well, I got two questions from Chris here. One, using containers, can you run across different cloud providers like AWS or Azure simultaneously?
So this is a complex question to answer. So I'm going to try and break it down into two simple points and give you a couple talking points. So the answer is yes, if you write your application to do so. So with that being said, there are ways that we have seen customers be able to do this, work across multiple cloud providers. And we've talked about different cloud providers, but we've also discussed private cloud and public cloud as a hybrid cloud scenario. That's kind of where the industry is moving towards now. The last couple of years, the industry has pushed very hard to get everyone into a public cloud, but there are certain use cases and certain customers who are saying, well, dropping several $1 million a month on infrastructure is great, but we haven't grown anymore. And so we want to start bringing some of these applications in-house, but we want a lot of that functionality to do so. So that's kind of a long-winded way of saying, yes, you can do that, but you have to build your application to be highly available, and you have to be able to point to those different clouds. So they all use public IP addresses. They all use different routing systems. So you can definitely do that. And there are plenty of customers we have as Red Hat references that are doing things like that.
All right. I think that was a good answer. One more question I have here. How does Red Hat charge for container management?
That is an excellent, excellent question. So the way that it works today is if we first, I want to explain that we don't sell licenses to Red Hat. We sell subscriptions. So we sell in 1 and 3 year increments, and we have based upon a subscription model. So think of it just like buying a newspaper. You get a subscription, it entitles you to a certain piece of it. So we have an operating system subscription for Red Hat Enterprise Linux. That allows you to run any version of Red Hat Enterprise Linux on any platform. So we don't charge per platform or anything like that. There's a few caveats in there, put a little star asterisk around the cloud providers because they do hourly charging. But as a subscription model, if you have a Red Hat subscription running on a Red Hat box and you're using Red Hat containers, the containers inherit the subscription of the host operating system. So if you have one subscription for a dual socket, 2-socket server, and you're running that, and you want to run 100 containers on that one server, all 100 containers will be legitimately subscribed to that one host machine, and that host machine has the subscription. So does that make sense?
Yeah, that does make sense.
Yeah, we do not charge per container as long as you have a subscription and as long as you're running on a RHEL operating system, a supported
Right.
subscribed RHEL operating system.
Right. All right, one last question I have here, and this looks like it was made for Tom. How does containers fit into the OpenStack architecture? And I know, Tom, you have a lot of experience with OpenStack. That's why I kind of queued you up.
I'll try my best to answer. So containers fit very well in the OpenStack architecture when they're combined a lot of times with another process, such as a software development process. And so containers are often used to wrap around those applications that might run then on top of OpenStack. They're also used to develop portions of OpenStack themselves, and in that sense, the reason they're used is because they're repeatable, so you can redeploy and redeploy the same thing over and over again with different variations. So containers work very well, and then honestly, they're used for a lot of, I would say, any add-ons on the side too, because they change so rapidly, and the benefit is they don't affect or have to change a lot of things with some of the core OpenStack components. So it lends itself to that modular kind of design. Matt, I don't know if you wanted to add more to that.
No, that was a great answer. There's a little bit I would like to add. With the upcoming release of RHEL OpenStack 8, so Red Hat has our own distribution of Red Hat OpenStack platform. And with that, we're actually tech previewing a container module for your Nova compute. So I don't want to get too deep into this. If they're talking about OpenStack, they probably know what Nova is, but we're actually tech previewing the capabilities so customers can test running their Nova service inside of a Docker container running on their private cloud. So we're actually have internally been testing containerizing all of those services to, like Tom said, to make them significantly more repeatable and a lot more scalable.
Well, I think that really wraps up our webinar today. We want to say thank you to everyone that's stayed on here for almost an hour with us. I hope it was worth the investment of your time. We'll be following up with emails and making sure you get this presentation. It will be available, replay will be available on our website within the next couple of days. Thank you everyone for attending. Thank you Matthew and Tom for contributing. And this is Kevin Vogel saying have a great day. Bye-bye.
Thank you.
Thanks everybody.